As we start section 1.2, you're going to notice that there are 4 different objectives related to 1.2. The first one is calculate mean, median, and mode given a data set. The second, you're going to learn how to write the mean in summation using sigma notation. The third, we're going to talk about computing weighted average. And then the last one is evaluate expressions using sigma notation and understand the order of operations. So let's just jump right into those notes. Now, when we talk about statistics, our first thing we're going to address here is the centers of data and weighted averages in this section. One of the phrases you might hear is measures of center. When they ask you to identify the measures of center, they're referring to 2 of the 3, either mean, median, or mode. The 2 measurements that give you how the data is centered is going to be the mean and the median. This book typically will not ask for the mean and the median. They're going to say measures of center, so you need to know that's what they are referring to. Now, I want to talk about just real basic elementary definitions of these 3 things. The mean, another word you might use is average. Okay? To find the average, for example, we have salary information here for 15 different individuals in this company. What is the average salary? What we would do is add up all the salaries and then divide by how many salaries there are. The median salary, another word for median is the middle. Which salary sits right smack dab in the middle? And then the mode is the most frequent. So let's actually take a look at the salary data and answer these 2 questions here. It says here in the Wacky Widget Company we have these 15 employees. The jobs and annual salary for each job are given in the table. A newspaper reporter reported that the average Wacky Widget worker earns $78,000 a year. Okay. Part A, which statistic was it reporting, the mean or the median? So when he said average, did he really mean the mean or the median? Take a moment and see if you can figure that out. So I'm going to pause the video for a second and see if you can figure it out. Okay, if you calculate the mean, add these all up and divide by 15, I'm going to tell you the mean is going to end up being 78. Okay, the median of this data set, the number right smack dab in the middle, is going to end up being 65. So he was referring to the mean. So he did kind of use that terminology correctly. Part B, why might most employees be upset by this newspaper article? Just eyeball, for example, all the salaries. Remembering the average salary was $78,000 when they added up all 15 and divided by 15. Why might these employees be upset? Well, if you take a look at it, the average, the middle kind of salary is kind of in the, we have some 30s, some 60s, some 20s. We have what we would typically call these outliers. We have some of these big guys here. We have the CEO in there, the vice president in there. 11 of these 15 employees make less than $78,000. So 11 of 15 make less than the $78,000. They're going to be upset. They're going to say, wait a second, something's happening here. So we'll get on to this later on in the chapter, but just look at the actual data and you can kind of get a feel of what might be skewing that data a little bit. Now, summation notation, this is going to be new to you. And it's right here in this kind of white box. And what it is, it's a Greek letter for sigma. So if you do the Greek alphabet, this notation right here, that is called sigma. It's the capital sigma. And whenever you see that, it means sum. To mean, it identifies to add. And here's how you would actually read this statement. It says, the sum of the x sub i's, so the sum of all of my x's, as I goes from A to B. So what you look at this, when you read this, you're going to see sigma, and this is going to tell you to sum. So it's going to say sum all of my x sub i's. Well, how many i's do I look at? Well, I'm going to go to this first one here. I'm going to start at A. This is my starting point. And I'm going to end at B. That's my ending point. Okay? So what I want to show you first is let me show you how to write in mathematical shorthand to tell someone to add up all of these pieces of salary, all of these data points. And here's what I'm going to do. I'm going to call them S's, for example. These are my salaries. I'm going to call it S sub I's. Okay? And the I, let me point this out. Notice here it says on the index, the I stands for, it says the number I, which indicates the position of the number. So it says go to what starting position and go to what ending position. Well, in these data sets right here, I have numbers 1 through 15. I have position 1, position 2, position 3, position 4. This person here is in the 11th position of how the data is listed. Okay? So if I wanted to tell someone to add up all 15 pieces of data, here's what I would do. I would say sum, I do sigma, and I'm noticing I'm using S instead of X, so I would say sum all my S's, and I'm going to say sub I's. Add up all my S sub I's, all those little S's. And they're going to want to know, where do I start? So I'm going to say go to the I, which is in the very first position. So go to the first position of the I, and I want you to add up all these down here. So you're going to have to go to the last position, which is 15. So you're going to say 15. So this actually says sum all of the salaries. Start at the first salary person and go up to the 15th salary person. And that is mathematical shorthand for writing out the sentence for that. Now what I want to challenge you to do is sum the salaries of the 5 people in the sales jobs. Okay, they want us to mathematically tell someone to add up the 5 sales rep managers and the rep. So we've got these 5 salespeople they want added up. Okay, how do you do that? Here's what you do. You say, I want you to sum all the salaries. And remember that little sub I tells you what position to go to. What position do you have to go to first? You need to go to the 11th position. So you're going to say, okay, go to the I's of first the 11, and then you have to end at 15. This is sigma notation, again, that says sum all of the salaries from the sales manager to the last sales rep. And that's all you'd have to do. Let me highlight one other thing of what this means. This actually says put 11 in for I. Okay, so what I would do is I would say I want my salary sub 11. And then it's sigma notation, which has sum. So then I would come in and say sum to it. Now from 11 I go to 12. Okay. Now it says, wait a second, I have to go all the way up to 15. So I say, fine, now I'm going to add to it the 13th salary. I'm going to add to it the 14th salary. And I'm going to add to it the 15th salary. Okay, well my S sub 11, this is S sub 11. Okay, that's in the 11th position. This is S sub 12, that's in the 12th position. This is S sub 13, that's in the 13th position. So it says come on in and add up all of those numbers together. Now the reason you want to understand sigma notation for summing is because it shows us how to write the mathematical definition for the mean or the average. And here's what it is. This is sigma notation. And it says this. We're using, if you notice, it says the sigma of all my x sub i's. So they're saying sum all my x sub i's. It says sum all of my x's, start at the very first x and go to the nth x, or the last one. So this up here says basically sum all the data. Okay? And then it's going to say divide by n, how many pieces of data you had. This is just another way of writing it. If I have sigma notation and I divide by n, that's the same as saying multiply by a reciprocal. So I can either say sum all my x sub i's as I goes from 1 to n, add them all up, and then divide by n. Or I can come in and say, wait a second, just sum all the x sub i's as I goes from 1 to n, and then times that just by 1 over n, because timesing by 1 over n is the same as dividing by n. All right, let's look at this example number 2. Here it is. A full parking lot has 46 cars in it. Let P sub I represent the number of people who rode in the ith car parked in the lot. So for example, if I had said, what does P sub 3 mean? P sub 3 would be the number of people who rode in the third car. Okay. P sub 5 represents the number of people who rode in the fifth car. So I physically count which car is in the fifth position and then count how many people. All right, part A asks you this. What does the summation of P sub I as I goes from 1 to 46 represent? Okay, it says sum all the P sub i's from 1 to 46. So what this represents is the actual total number of people who rode in the cars parked in the lot. Okay, so total number of people who rode in the cars and parked in the lot. Be very specific. That's what this is about. Okay. Now, what they want us to do in part B is use sigma notation to express the mean of the number of people per car. Easy enough. To find how many people per car, I would say sum all the people in the cars. So sum P sub i's as I goes from 1 to 46, and then I would divide by 46. You could write it that way, or you could say, you don't have to do both, I would just say sum all my P sub i's as I goes from 1 to 46, and then I'm going to multiply that by 1 over 46. Okay, means exactly the same thing. Okay, we have 4 more slides to look at. This is actually quite an important one, weighted average. And this is very relevant to everyone in class, is how your GPA is calculated. And let's just take a look at it. Weighted averages. In our grading system, and ours does work the same way, the letter grades have their corresponding number point system with it. So we have a categorical variable that has a numerical value. We have Susan's report card here. Looks like she is taking 5 different courses. Here's the number of credits per course. You're going to notice keyboarding. She's probably only in keyboarding 1 day a week since it's only 1 credit. In AP Calc, she's in that 5 days a week. Here's the grade she got, and here's the grade point associated with that letter grade. And what they want us to do is use Susan's report card to find her GPA. Okay. What people are tempted to do, and this is the incorrect thing to do, is they're going to say, okay, great. I'm going to add up all of her grade points and then divide by 5 classes. If you added up all 5 of these numbers and divided by 5, that would be equally weighting every class. That would mean keyboarding counted the same amount as calculus, but it doesn't. She's taking by far fewer credits in keyboarding than in calculus. So what you have to do is a weighted average. And here's what a weighted average is. A weighted average says this. She has 1 credit worth 4 points. She has 5 credits worth 2.67 points each. 4 credits worth this many points. 3 credits worth this, and 3 credits worth 2 points. So you're going to figure how many total credits that would be, or how many total points that would be, and then divide by, you want the points per credit. So we want to know her points per credit. Folks, in math, per just means divide. So this is the points divided by the credits. That's how you find a weighted average. So the credits, if you count these up, 1, 5, 4, 3, and 3, that's going to give us a total of 16 credits. Okay, she has 16 credits, so that's what's going to go down here is 16 credits. Well, how many total points does she have? Well, this is the tedious part. Here's what we have to do. We do 1 credit at 4 points, and then we're going to add to it 5 credits at 2.67 points. Then we have 4 credits at 3.33, 3 credits at 0.67, and then 3 more credits at 2. You add all that up, it's going to give you all the points, all the grade points. So you take all those grade points and you divide by 16. And what you're going to get is her GPA is going to be about a 2.42 GPA. So Susan here is somewhere, right? She's going to be at a C+ is where her grade is probably going to be sitting right now. So just be very careful in this scenario. Again, the most common mistake is to add up all 5 of these and divide by 5. Now, if these numbers had all been the same, this equal amount of credits per class, you absolutely could do that. But because they're not equally weighted, you have to get the total points and then divide by credits. So the points per credits is what you do for weighted average. Okay. This is just another example of weighted average and how it works. So let's take a look at it and see if it makes more sense. Alexis wanted to buy a ticket to a concert. She saw the ticket prices were $20, $30, and $100. She wrote a letter to the concert promoter saying, an average price of $50 is way too much for a concert for teenagers. Would you agree with Alexis that the average price of the ticket is $50? Now, it looks like what Alexis did is she said, okay, I've got the 20 plus 30 plus 100 divided by 3 different types of prices, and she got $50 per ticket. Okay, is she right? Take a look at the data they gave you, by the way. Look at all the information in the problem. Ticket price and availability. Okay. So as you look at this, the availability of these tickets is not equally weighted. You cannot do a normal average. She has to do a weighted average in this case. So she needs to know the total price per tickets, right? Price per ticket. So how do you find the price per ticket? You get the total prices over the total number of tickets. Well, how many total tickets are there? In here, there's 1,520 tickets. How much money, what was the price or the money that they collected for all these tickets? Well, we had 1,000 tickets at $20 a pop. We had 500 tickets at $30 a pop. And then we had 20 tickets at $100 a pop. Okay. If you add up the numerator and the denominator, you're going to get the weighted average ticket price, was $24.34. So Alexis is way off on this and then just fully doesn't understand the mathematics behind this. Now here I just want to address a different vocab word. We're talking about frequency versus relative frequency. So relative frequency, before I get to that, let me just address frequency. Okay, when I say what's the frequency of how many people have blue eyes in class? Frequency is the count. So we would figure out a count. Okay, relative frequency is very similar, but what it is, it's a ratio. It's a ratio, or what you could say, it's a percent. So it's a ratio of the number of times an event occurs to the actual total number of events. So just remember that. When you hear frequency, it means the count. Relative frequency means a percent of that count. Okay, so we're back to the tickets that Alexis was looking at. Here's what they want us to do. Convert the frequency table and graph for the concert tickets to a relative frequency table and graph. Okay, all they want us to do is this. We need to change, this is frequency right here. Relative frequency means the percent. So I'm going to call it relative frequency. And it's just a percent. Percent of the total. Well, folks, this totaled 1,520 tickets. The $20 tickets are what percent of the total? Okay. I'm just going to do 1,000 divided by 1,520. And when you change that to a percent, it's going to be about 66%. Okay. This next one, I'm going to take the 500 divided by 1,520, and I'm going to get about 33%. Take 20 divided by 1,520, you're going to get about 1%. Okay. The total here is 100%. That is the relative frequency. Relative frequency, by the way, can be written as a percentage or as a decimal. They are both acceptable. Now they want the graph, though, to be not a frequency. This is the number of tickets. That's a count. Fine. We're going to make it a relative frequency graph, so it has to be percent of tickets. The highest percent of tickets is 66. So fine, I'm just going to do this. I'm going to do change this. I'll make this 0%. I'm going to go 33, 66, maybe 99 for counting nice scales. And then we'll just do the types of tickets. We have the $20 ticket, the 30, and the 100. And then do the bar graph. We have here 66% are the 20, 33, and then the little 1 right there. And that would be a relative frequency bar graph. All right, part B, compute the weighted average using the relative frequencies and compare the results. Okay, well, here's what they're saying. We did the weighted average using the counts on the previous slide. Okay, that's where we said, showed the calculation, 1,000 tickets are $20 and so forth, and added them up. Let me put the percent here. This is 66%, 33%, and 1%. You can do weighted averages one of two ways. You can do what we did on the previous slide, get the total count, and then divide by how many tickets. Or what you can do is you can say the $20 tickets, there's 66% of them, and add to it these. So what I would do is say I have 0.66% of the $20 tickets plus 33% are $30 tickets plus 0.01% is a $100 ticket. And if you compute those in the calculator and add them up, you are going to get that the average ticket price is $24.34, which is exactly the same thing. Well, folks, here's what this stuff means, okay? 66%, where did that 66% come from? That originally, by the way, was the number 1,000 over 1,520. And then keep the 20 there, right? Now add to it, where was the 33%? Well, the 33% was the 500 tickets over the 1,520 times the 30 tickets. Okay? And then we did the same thing here, running out of space, sorry. The 1% was the 20 tickets over the 1,520 times $100. That's exactly what we did on the last slide. It's the same thing. We have here three fractions. They all have the same denominator, so you can add the numerators up and keep the same denominator. If you do that, what it's going to look like is this. It's going to say 1,000 times 20 plus 500 times 30 plus 20 times 100 all over 1,520. Well, we just did that. You don't have to do this two different ways. Pick one and just do it that way to get the weighted average. Now for this last slide, it's using the graphing calculator to get the mean with and without a frequency table. I will show you, after we do the entrance card, how to do means with the calculator. I think it'll be easier than me trying to do it on here. If you want to, you're more than welcome to now look at the assignment. It's scheduled right now is for 1 through 19. Hopefully you can take these notes before you get to class. Try the entrance card. If you get the entrance card correct, you will have modified homework, and I will tell you what that modified homework is when you get to class. And also, I may just shorten this a little bit. I'm not sure quite yet for the normal regular assignment. So good luck with the homework.